here's a complete explanation of how standing waves are formed. Got it? Okay, well, I'm going to have to reconstruct this. There's too much here to just point to, so I'm going to have to reconstruct this a little bit at a time. But what we see here is a white wave that we think of as moving in this direction, and a red wave that we think as being a reflected wave moving in this direction. In this picture, the waves are equal and opposite at every point, so that the displacements, the y displacements, always add up to zero. Whatever's on this side of the equilibrium line or the axis, we have the same thing on the other side, so this adds up to zero. If we shift the wave a quarter of a wavelength, now wavelength runs from here to here, shift the wave a quarter of a wavelength, and everything comes into phase. This peak shifts over here, and this peak will shift over here. And the same thing will happen all along the wave, so when you have two peaks, they're going to add to give you a peak twice as high. When you have two valleys, they'll give you a valley twice as high, etc., etc., etc. Then shift another quarter of a wavelength, and they're out of phase again. This time, the red is above the white on this particular interval, and they're going to have reversed on every interval, and they're going to add up to zero again. Here we have them once more. Okay, we shift the red one more excuse me, half wavelength to the left, the white one more half wavelength to the right, and again they're in phase, and we get a reinforcement that gives us this configuration where this wave is now down where this one was up, so that on a short interval, let's say this interval from here to here between these two lines, we go from level to a peak above the axis, back to level, and then to a peak below the axis, so that the wave is moving up here, then back to equilibrium, then down and back to equilibrium, back and forth. Maintaining a node, a point of zero displacement on this line and on this line, so at the endpoints we have zero displacement. In the middle we have maximum displacement. Now, we don't always have maximum displacement, but when we do have it, it's halfway between these 2 points. So there is the basic idea behind the evolution of a standing wave, or the production of a standing wave. But there's a lot more that we want to say, and we want to talk about how we can use this picture. So we're going to start at the beginning and do this a little more slowly.